Hello, everybody. So you made it. You have completed level 1 of clinical development, understanding time to event endpoints, Kaplan Meier estimates, and you can read curves in the literature. Congratulations. This is about as much as most people in the field know about the topic. But let me tell you, there is more. And the fun is just starting now. The PFS paradox can be considered a hidden scandal of Kaplan Meier curves. In this very short video, I will remind you what the definitions of progression-free survival and overall survival are. I will briefly describe a patient population and a situation in a clinical trial as it did happen, and I will show you how OS, overall survival, appeared shorter than PFS, and how that could happen. The definition of time to event endpoints was shown in a previous video. Overall survival is our gold standard, and by definition, it starts with either initiating the drug treatment or a randomization, and it ends with the patient passing away. Progression-free survival, in contrast, starts with the same starting point, but it ends earlier when tumor progression has been detected, or with death, whatever occurs first. It cannot be that progression-free survival in an individual patient is longer than overall survival. There are 4 scenarios that come out of those definitions for the progression-free survival Kaplan Meier curve and the overall survival Kaplan Meier curve. The best of those scenarios is the patient does not experience a progression and is alive and well in the end of the observation time. Then both of the curves will be censored. Censored is a good thing in the context of Kaplan Meier curves. Second scenario is the patient does pass away in the observation time. However, there was no progression of the tumor detected before. That can happen when the diagnostic methods fail and the progression was there and wasn't seen, or it can happen when the death is really unrelated. In that case, both of the curves will have an event, and the date of the event will be the date of death. The reverse situation is possible as well, that there is progression noted, but the patient is alive at the end of the observation time. Then progression-free survival will have an event and overall survival will not. And the worst case, which is unfortunately very common in oncology research, is that the tumor progression was noted and the patient passed away later. Then there are events in both the progression-free survival curve and the overall survival curve, but the date of those events are different. In the study, for which I will show you the curves in a few seconds, we mainly only had 2 of those patient populations. There was a large number of patients where things really went well. We had no progression, and by the end of the observation time, the patient was alive and well. There was a second also sizable number of patients that had early progression. The drug just did not work. The investigators, the treating physicians, switched the treatment to something else. There were effective treatments available, and they prevented further progression, made the tumor go away for a while. But the far majority of those patients eventually passed away anyway. This is what the curves look like. Let's start on the left. The progression-free survival curve had a fairly steep drop with several patients very early on. As I said, there were patients where the drug just didn't work. The overall survival curve, as it should be, was to the right and above of the curve. But then the curves crossed. How can that be? And even more so, when they finally crossed the 50% line, the progression-free survival curve was to the right of the overall survival curve, and the median overall survival estimate was shorter with 5.5 than the median progression-free survival estimate, which was 8.5. This doesn't just happen in that trial. It actually happens more often than you would think. It just is never shown. This happens when, first of all, there are many censored data. And we had all of these check marks indicating censored data in the progression-free survival and the overall survival curve. The check marks are the same patients. It's just the end of the observation time for those patients. It happens when many of the progressions occur before, as it was in our patient population. Many progressions were very early, and it was before the censored data. And then finally, it happens when the deaths occur after the censored data. The reason why that happens is the way Kaplan Meier calculates. Every patient that has an event causes a drop, a step down of the curve. This patient was the first one that caused a step down of the progression-free survival curve because the patient experienced a progression. But at that time, all the other patients were still in observation. So the percentage of patients progressing at that time was very small. In contrast, that step also is only one patient. But at that time, there were only 4 patients left in observation, the patient that had the progression here and those 3 patients that didn't have progressions. So the curve dropped by 1/4, 1/4 of the height of the previous curve. The deaths that we had to recognize happened mainly after the censored data, after the time where the good patients were out of observation. Therefore, each of those events, these death events in the overall survival curve, was only counted by a small number of patients still in observation, and therefore each of the steps was larger, and the overall survival curve dropped below the PFS curve. It is impossible that PFS is longer than OS. But when you aggregate data, funny things can happen. And if you do it with the Kaplan Meier curve, the PFS curve can appear longer than the OS curve. We call that the PFS paradox. And it is a hidden scandal of Kaplan Meier curves. You may consider actually keeping it hidden, because these curves do not reflect the real biology. They do not describe the patient population correctly. That Kaplan Meier curves are bad because of that. Those are still the best way to describe patient populations where some of the patients have censored data. Thank you. Bye-bye.